If it has a positive charge, do y'all know what that's called? Cation. Positively charged particles are known as cations, and negatively charged particles are known as anions. How would an atom get a positive charge? Okay, if it's made of protons, neutrons, and electrons, what are you going to change about an atom to give it a positive charge? You're not going to change the protons. The only thing that can change to make an ion is the number of electrons. For example, if I were looking at an atom of sodium, do you know how many protons an atom of sodium has? $11? Yeah, because we look at the periodic table. Remember that? The blue number in the top right, the atomic number is the number of protons. So sodium would have 11 protons. How many electrons would sodium have? It would likewise have 11 electrons because that sodium is neutral. So the protons and the electrons have to balance each other out. Now, do any of you know what kind of charge sodium likes to have? There's only one kind of charge sodium can have. Do y'all know what that is? Positive 1. So when we have sodium with a +1 charge, how many protons would that have? Still 11 protons, because we can't change the number of protons. How many electrons would it have? 10. Do you see that? It would have an excess proton, so it ends up with a positive charge. So again, an ion is a charged particle, and it gets the charge by changing the number of electrons. That's the only thing you can change, because if you change the number of protons, you're changing the identity of the atom. Now, let's look at anions. Chlorine. How many protons, how many electrons would a neutral atom of chlorine have? Yes. It would have 17 protons and 17 electrons. Do any of y'all know what kind of charge chlorine likes to have? Chlorine likes to have a -1 charge. So how are the protons and electrons going to change for a chlorine with a -1 charge? Still 17 protons and 18 electrons. So in order to become a cation, we take away electrons. In order to become an anion, we add electrons. So first of all, if we look at a periodic table, and I know the one I have here has a lot more colors than the one in your book, but I think we've pointed out before this stair step that comes down through here, right? That stair step separates the metals. Everything over here on the left, those are metals. Everything on the right, those are nonmetals. And if we look at a periodic table that actually shows charges, do you guys see that all the metals, and in your book those metals are in green, but all the metals have a positive charge? Okay, so metals form cations. And the nonmetals, which are in blue, they all have a negative charge. So for now, we'll think of metals. Well, metals are always positive. Nonmetals are negative, even though they can be other things that we'll see later. Okay, but metals are always positive. There's also another pattern that you can see on the periodic table. Do you remember which group is alkali metals? 1. Group 1, those are known as alkali metals. And if you look at that table, everything in group 1 has what charge? A +1 charge. What about group 2? Those are the alkaline earth metals, and everything in group 2 has a +2 charge. And then I'm going to skip the transition metals. Okay, these are the transition metals right here. I'm going to skip over those, and go to aluminum, what charge does aluminum have? +3. So coming from the left, eliminating the transition metals, I go +1, +2, +3. Now let's go from the right. The first column we have here, those are noble gases, and we know those as inert, essentially inert. What does inert mean? They don't react, okay? So the noble gases don't have a charge. That's why you see nothing written in that column. Then we go to group 17. Do y'all remember what those are called? Halogens. Group 17, those all have a -1 charge. Group 16, those you see have a -2. Group 15 has a -3, and then carbon in group 14 has -4. So that's how we know what kind of charge sodium likes to form. In the example we just went over here, sodium with a +1 charge. Because sodium is in group 1, I know it would have a +1 charge. Because sulfur is in this group, I know it has a -2 charge. Because chlorine's here, I know it has -1. Okay, and we remember that pattern. Now, we also see that the transition metals, if you're looking at that periodic table that you see in your book, there's really not a pattern to the transition metals. Do y'all see that? And some of those have more than one possible charge. Okay, so there is no pattern to transition metals.